Okay, this is going to be a lesson on SLT 23, identifying the effects on a graph of a rational function by replacing f of x with f of x plus k, k times f of x, and f of x plus k for specific values of k. Homework tonight is pages 13 and 14 in your packet, and I would like you to please pause the video and complete pages 7 and 8 in your packet. This should be done without a calculator. Okay, so ideally you put in some really basic numbers for x, like just, -1, -2. You can see I started putting a couple fractions here just to get some better values. And what I find is I have these two disjoint curves, these two unconnected curves. And I notice that vertically and horizontally I have an asymptote. You can remember asymptotes from our study of logarithmic functions and exponential functions. I see I have a horizontal asymptote right here, and I have a vertical asymptote right here. And because we're going to be very concerned about the location of these asymptotes, I want everyone on the side to make a note that we have a horizontal asymptote of y equals 0, and we have a vertical asymptote of x equals 0. And that's our parent function of the rational function 1 over x. On page 8, you were supposed to graph 1 over x squared. And again, hopefully you picked a variety of numbers, and you end up again with two disjoint curves. The difference is on page 8, these curves are symmetrical over the y-axis instead of having odd symmetry. And again, I want you to pay attention to their horizontal and vertical asymptotes. We have a horizontal asymptote at y equals 0, and again we have a vertical asymptote at x equals 0. I'm going to add that in. Horizontal asymptote of y equals 0 and a vertical asymptote of x equals 0. And while I'm making some notes on these parent graphs, I'm also going to note on the side that the graph on page 8 has odd symmetry. And I'm sorry, not odd symmetry, even symmetry. And the way I know that is that it is a reflection over the y-axis, and every point x, y has a corresponding point -x, y. So while we're making notes about these parent graphs, go ahead and flip back to page 7 and let's make a similar note for 1 over x. 1 over x has odd symmetry. And remember, this means that we have rotational symmetry. (180 degrees) around the origin. And every point x, y has a corresponding point (x, y). We're going to refer back to these as we go through today's lesson. So I want everyone to go ahead and turn to page 9. And on page 9, we've got a transformation of our parent graph of 1 over x. Now take a second, just so we all use the same values, let's all use the same values. Let's use the values of 1, -1, 1/2, and -1/2. -1, we'll do 1/2, we'll do -1/2. Let's do 2 and -2. Just some nice easy numbers. So if I plug in 1, I'm going to get -1. If I plug in -1, I'm going to get +1. if I plug in 1/2, -1, let me do this off the side real quick, -1 divided by 1/2 is like -1 times 2 over 1. It's going to be 2. And then if I do -1/2, that'll be -2. Oops, that was -2, sorry. This is 2. And then -1 divided by 2 is just going to be -1/2, and this is going to be +1/2. So as I graph these 1, -1, oops, yeah, 1, -1, 1, -1, 1, 1/2, -2, -1/2, +2, I see that I'm ending up with the same curve as I did on page 7, but I have a reflection over the x-axis. So I'm just going to fill in my graph. I know what the shape looks like from the parent graph. Sorry that my lines aren't straight. And I definitely want to mark those dotted asymptotes because just like with logs and exponentials, we want to be really clear about our asymptotes. And we see that the asymptotes have not changed. We still have asymptotes at horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. And then it says, how does the graph compare to the parent graph? We want to make a note that we have a reflection over, why is this so big? Over the x-axis. Now, this graph is a little tricky because it has rotational 180-degree symmetry. You could look at it like, oh, this is a reflection over the y-axis because visually it kind of looks like that. But we want to remember that when the negative is in front of the function, like it is here, it's over the x-axis. If the negative was placed specifically in the argument, in the denominator, we would say it had y-axis. It had a y-axis reflection. So go ahead and try number 2. Put in the same numbers. We're going to put in 1 and -1. Ooh, oh man. Going crazy. 1, -1. And if I do that, I get 3 and, oh, I get 3 again because it's squared. That's exciting. And let's do 2 and -2, and we get, oh, that's ugly. That's okay. We get 3/4 and 3/4. Let's do 1/2. I always like 1/2. 1/2, -1/2. So if I do 3 divided by 1/2 squared, I've got 3 over 1/4, which is going to be like 3 times 4 over 1 gives me 12. And because I'm squaring the 1/2, this will also give me 12, which is probably off the graph. Oh well. Let's see, we got 3, we got 2 3/4. Put that like there, and then this one's way up high. Put that up there. And we have our curves. We know what the parent graph looks like, so we can use that to guide us. There's one side, and there's the other side. Ooh, that one's not as pretty. Sorry about the lack of beauty in the curves. And again, very, very important to get those dotted asymptotes in and make sure it's clear where they are. And again, not much excitement yet because we still have asymptotes at y equals 0 and x equals 0. So underneath it says, how does the graph compare to the parent graph? And we know that whenever we have an a value in front of our function, kind of like we do here, because this is like 3 times 1 over x squared, we have a vertical dilation of 3. Cool. All right, whoops, too far. All right, on page 5, we have, that is not page 5. That is number 5, there we go. On page 10, we've got 2 more graphs. I'm not going to do a lot of points here because I remember all my transformation information from previous units, so I'm just going to put in what I think will work nicely. I'm going to put in 1. I'm going to put in -1. I'm going to put in 2. I'm going to put in -2. And I'm going to see what happens. So if I put 1 in here, I get 1/3. If I put -1 in here, let's see, -1 plus 2 is 1. 1 divided by 1 is 1. If I put 2 in here, I get 1/4. And if I put -2 in here, I get undefined. Okay, so immediately I'm like, wait a second, this is different than my parent graph because 1 and -1 before gave me odd points. So I don't think this function is odd anymore. And for those of you who are real good smarty pantses already know, Miss Strauss, this graph just moves left 2 because it's got a +2 in its argument. So we'll get some more points in there just for fun though. So if it moves left 2, that one's undefined. Let's go to the other side. Let's do -3. So if I put -3 in there, -3 plus 2 is -1, and I get -1, and here's -3, -1, and here's our point at -1, 1, and then we had a point, we could put 0 in there, that'd be easy, 1/2, and there's 1/3, and then if we put in -4, that would be -1/2, and I can kind of see I'm starting to get the same shape as before. So I'm going to grab my asymptote tool. I'm going to put in my vertical asymptote, my horizontal asymptote. Oh, that one's a little crooked. I can do better. There we go. And now I'm going to sketch in my curves. And again, I'm going to use my knowledge that the graph moved left 2 and what I know what the parent function looks like to get a nice smooth curve. Whoops, that one went up a little high. Pretend it's down here. And then one over here. Alright, so it has moved left 2. Horizontal asymptote is still y equals 0, but now my vertical asymptote is x equals -2. I bet you can guess what is going to happen. We have a -2 outside the argument. So I have this parent graph of 1 over x squared, and take a guess what is going to happen. Don't say it out loud. We don't want to spoil the surprise for those people who don't know. So we're going to have 1 squared, 1 minus 2 is -1. -1 is also going to give me -1. I can't put in 0. Let's do 2. So that'll be like 1/4 minus 2. It's going to be a fraction. We can handle it. -7/4. This one's also -7/4. Oh, wait a minute. That's not -1. Yes, it is. And now we're going to have, so that'll be like 1/4 again. So let's just get these graphed. And again, I know what the parent function looks like, so I'm going to put my asymptotes in at y equals -2 and x equals 0, and I'm going to use my knowledge of what the parent function looks like to sketch in some curves that aren't super duper ugly. Well, that one looks a little bad. Oh, almost missed the point. All right, we have a horizontal asymptote now of y equals -2. Vertical asymptote is x equals 0 still. And how does this compare? It moves, got a translation down 2. So what I'd like everyone to do is pause the video and see if you can do page 11. No, wait, I'm a big liar. Don't do that. We gotta start page 11. We're gonna start page 11 together, and then you're gonna finish it while the video is paused. So here's the deal. All of a sudden, we are changing the way we are writing this. So here is our argument. It says, for each function, fill in the table and sketch the graph. Well, first we have to write this in a way that we can understand it. So if our argument is now x minus 2, and this is f of x, so where the x is, we're going to put x minus 2. So it's going to be g of x equals 1 over x minus 2. And then we've got this plus 1 here, and so that is going to happen outside of f of x, or outside the argument. So g of x is 1 over x minus 2 plus 1. When we look at numbers, I know it's a funny problem. If we look at number 6, we've got g of x equals, again, the argument is going to become x minus 2, but now we're using that squared function, that one that starts off even. I wonder if it stays even. We'll find out. And we're going to add 1. So go ahead and pause the video and graph these two functions. Okay, this is what the graph of number 5 should look like. You should have a horizontal asymptote at y equals 1 and a vertical asymptote at x equals 2. I know some of you are thinking, Ms. Strauss, how did you know to pick 3 and 1 for your points? Well, I'll let you in on a little secret. First, I find my vertical asymptote, which is at x equals 2. Then I go 1 unit to the right and 1 unit to the left. And most of the time, those will give me nice, clean integer answers. Most of the time, sometimes not, but most of the time. For number 6, oh, and it went right 2 and up 1. Number 6 is very, very similar, except that the parent graph is different. And again, to get my 2 good points, I went to the right of my vertical asymptote and I went to the left of my vertical asymptote. What I'd like everyone to do is we're going to turn to page 12 and we're going to practice rewriting functions from this function notation form into a usable function form and back and forth. We are also, because we are an honors class, going to add some properties because otherwise it's a little boring. Here's what I mean. So here's g of x. The argument is x minus 3, so that's going to be our x minus h. There's a 1 in our numerator, so I don't really need to put, if I wanted to, I could put like 1 time, but I'm not going to do that. You can if you want. I've got f, my argument is x minus 3, and outside is plus 1. And I want you to also state the vertical asymptote, the horizontal asymptote, the domain, and the range. Since we aren't making graphs, let's think about domain and range for a second. We have this function that went right 2 and up 1. The domain is actually every single number except for the asymptote. Every other x value will have a y value. When I look at the range, so we'll just write that one down. Domain, all reals, x is not 2. Now the range is going to be all reals, but now I hit every y value except the asymptote. I know some of you are thinking, Ms. Strauss, does that mean that the domain and range will always be all real numbers except the asymptote values? And the answer is yes for the domain, mostly for the range. Don't make that a rule in your head. For now, that's how it's going to work, but not for always. Sometimes graphs will cross horizontal asymptotes, but not today. So for today, we know we have a vertical asymptote at x equals 3 because the graph goes to the right 3. And horizontal asymptote is going to be up 1, so it's going to be y equals 1. That means our domain is going to be all real numbers, x cannot equal 3, and the range will be all real numbers, y cannot equal 1. So I'm going to just help you out here because I don't like the way this one's written. That's kind of weird. That just is the same thing as 2 over x plus 1, negative 2 over x plus 1. So go ahead, pause the video, and finish these 4 problems on page 12 and also state the 4 properties I'm asking for.
Okay, bye.
Okay, so here are the answers for A and B, and you'll notice that I'm also just making some notes on the side for myself what the transformations from the parent function are. And here are the ones for the parent function of x squared. And again, I made a couple notes for myself about what the transformations are. Go ahead and start the homework on page 13 and 14. I'm going to go forward and let you see the answers, and they'll also be up on Drive. And we're done.